So I've got my IntelliJ open in presentation mode. Let's solve this problem here. And I will take the same method name. Final. And if you look at this, let's check for the base condition. So the num's length would be at least starting from 1 to this value. So if it's 1, right, in that case, we can simply return that number. So for the base condition, if and simply return nums 0. Now we have to implement this algorithm that we have reduced in our previous video. Let's start with the default result first. So the default result is the max of this array, right? This would be our default result. And then we'll use this formula going forward by maintaining current max and current min. Let's do that. So result default would be, I will just use array stream of nums dot max and dot get as int. Here it is showing me some warning because I'm not checking whether this optional int is present or not. But we have already ensured here that the nums of length should be at least 1, and it cannot be null anytime. So it will be always present here. So result, we have taken the maximum of this array. And now let's initialize our two variables, which is current min is equal to 1 and current max. Right. So current max and current min. Okay. And now we need to iterate through all of them, calculate dp0 for all of them one by one, and come to the final solution. So here I will use for each loop for iterating through all of them. Final int nums and although we have been using like temp1 and temp2, but temp2 we can just use a single variable and just replace that in this formula here. And I'll show it here. So we can simply, the second temp is redundant. So that's why I'm just maintaining this one single, which will store the current max multiplied by the number itself. So this is temp1. So only this number we are storing. Temp2, I think, is redundant, as said. So let's calculate the formula now. Current max is equal to you see, right? The formula of current max is temp1, temp2. Temp2 is nothing but current min into num0. That's why I'm not storing it at temp2. So it would be temp2 is current minimum multiplied by the number itself and the number. Okay, this is temp1, temp2, and num5. So it would be, let's start with the number multiplied by current max, which is temp1. And because we don't have, like in Java, we don't can provide 3 arguments to max. So that's why I'm using it this way. So max of this first variable and the max of the remaining 2 variables, which is num. This is our current min, right? And the number itself. So this is temp1, this part, this is temp2, and this is the number itself. The same formula as we have derived here, right? And then for current min, it would be math dot min of the same thing, right? Temp1, temp2, and nums. I. So it would be here. I mean, we can use temp because our current we cannot use num into currentMax because currentMax have been updated here already. That's why we have stored it into a temp variable before. This is our original currentMax, and now in this line we manipulate this currentMax. That's why we cannot use the same formula here. That's why I'm using temp, the previous value of currentMax, and then here it can be still same. It could be, yeah, it's minimum of this, right? So it should be minimum of, this is temp2. Temp2 is current min into num and num itself. So that's why I mentioned that I'm just storing this only one variable, because we can directly use this num into currentMax as temp1 and temp2 as current num into current min. We don't need to store a lot of variables, and we are storing temp here so that we don't use the updated value here in our current min formula. So that's it about this, guys. This is all of the formula that we have, and then finally the result would be math.max of result and currentMax. That's it. This is all the algorithm that we have derived and has been implemented here. And in the end, we have to return the result. So again, revise this. If the nums length is 1, we return the first, because only one array's element is present. That would be the max product of that. And then we found the default value of result as a maximum of the nums array. And then we started like calculating the current max and current min, starting with 1 for each of the numbers. So the formula that we have created here, current max, that is max of temp1, temp2, and nums I. Similarly, we have done here. So it's just temp1 and temp2 and the number itself. And the same formula has been applied for current min. And then we take the maximum of the result and the current max, and then return the result. So let's run this and see whether our output is correct. So we go here and I'll take this. Okay, and max product, new int, and then similarly for the second 2 minus 201 minus 1. So I've also introduced this third case, which we have discussed here. If it's -4, then the answer should be 48. So let's try for all these inputs. I'm running this now. Okay, so it's 6, 0, and 48. 48 is correct, 6 is correct, and 0. So 6, 0, and yeah, done. Other case. So our sample input is working correct. So let's copy this and try it in the lead code, covering all the different test cases. Let me put it here. Submit it. Yeah, so it works well. Ours is success. So let's quickly check the time complexity and space complexity. So the time complexity would be O of n, because we are only having one loop. We are iterating through this array only once. So it would be O of n. Similarly, space complexity, we are not storing any additional array or anything. We are just creating the 2 or 3 variables. So it would be O of 1. So that's it about this max product subarray. Time of having only like a very good approach, just solving this in these 3-4 lines. So we have solved 11 problems so far. And in the next video, we'll solve our 12th problem in our dynamic programming tutorial series, which is the longest palindromic substring. This is another very classic dynamic programming problem, and it would be the 12th of our series. Our target, as discussed, is to solve 50 most popular problems. So see you in the next video for solving our 12th problem.